On a Linux file system, two things look like copies of a file but work in completely different ways. Hard links and symlinks both let you access the same data from different names, yet they survive, fail, and behave differently. Here's what's actually going on under the hood. When you save a file on Linux, the file name isn't where the data lives. The file system creates a structure called an inode. Think of it as a card in a catalog. That inode holds the file size, permissions, timestamps, and pointers to the actual data blocks on disk. The file name is just a human-friendly label. This separation between name and data is the key to understanding both types of links. A hard link creates a second file name pointing to the exact same inode. There's no copy and no shortcut. The second name has equal standing with the original. If you delete one name, the inode's reference count drops by 1, but the data stays on disk as long as at least one name still points to it. Hard links are limited to a single file system, and on most systems, you can't hard link a directory. A symbolic link is a tiny file that stores a path string, basically a note that says, look over there. It has its own inode, completely separate from the target. When you open a symlink, the kernel reads the stored path and follows it to wherever it leads. That flexibility means symlinks can cross file systems and point to directories, but the trade-off is real. If the target gets moved or deleted, the symlink is dangling. Look at the three file names at the top. Both original.txt and hardlink.txt connect straight to the same inode. They share it as equals. The symlink sits on its own inode, which stores a path string instead of data. Follow that path, and you arrive at the same shared inode. All three names reach the same data, but a hard link gets there directly while a symlink takes a detour through a stored path. Hard links are great when you need the data to survive no matter what. Think backups or deduplication where deleting the original shouldn't matter, but they can't cross file systems or link directories. Symlinks give you flexibility, they span file systems, point to directories, and you can see where they lead at a glance. The price is fragility. If you need resilience, pick hard links. If you need reach, pick symlinks. Let's see this in action. We create a file, then make a hard link and a symlink. When we list inodes with LSA there, hard link shares the same inode number as the original, same file, two names, same file, two names. The symlink has a different inode and an arrow showing its target. Now we delete the original. The hard link still prints the data, no problem. But the symlink, it breaks. It was pointing to a name that no longer exists. Hard links point to data. Symlinks point to names. Once you see it through the inode lens, the rest clicks. Thanks for watching Awesome Linux TV. Bye-bye.